Okay, so Algebra 2, we're off. We're our second day in section 4.2. This is our last lesson of learning for a couple days. So yesterday we did 167 from 1 to 12. I'll read you those answers first, and I can help you troubleshoot that first. Then I have got some more sample questions to help you finish this. The new homework will go to 26. On our present calendar, tomorrow's Thursday. 2 classes away, which is Friday for us, a sheet would be due. The sheet will review 4.1 and 4.2. So we spent 2 days in 4.1, 2 days in 4.2. It's like 4 lessons worth of stuff. Sheet review Friday, which puts us at a quiz Monday. So that's just where we are in terms of calendar. On this 1 to 12, odd answers are in the back, so you could have looked those up there. Even answers, I'll just give them to you, and then we'll see if you need me for something. So number 2, it just wants 2 numbers, so we don't need labels. They're both negative. It's negative 11, negative 52. 4, they want numbers, so we don't need labels. They're positive numbers this time. There's a 29 and there's an 18. 6, there's percentages of things, so we want to label these somehow. There's 4 liters of the 25% stuff. And there's 6 liters of the 50% stuff. So don't just say 4 and 6, but have those labeled. 8, similar to 6, should have labels. There's 12.5 versus 7.5. There's 12.5 either of A, because they gave it the name A, or you could say 12.5 of the 18% stuff. For the 7.5, you could either call that B, because they named it, or 10%. When we go to 10, 10 is 6,800 and 8,200 are the numbers. 6,800 labeled as 9%, 8,200 labeled as 10%. 12 is 12,500 and 14,500. The 12,500 is the 10% investment, and the 14,500 would be labeled as a 12% investment. Although really in the real world, if you could get 12%, you would just invest all your money at 12%. Why would you put any money at 10% if you could get 12% somewhere else? That's just kind of stupid. But anybody on those?
What was the answer for number 6?
Answer for 6 was 4 and 6. 4 of the 25% or A, however you label it.
Can you set it up for me? Because I feel like I got it set up right, but I got the answer completely wrong.
So does your table go in the first column X, Y, 10?
X, Y, 10, yeah.
Middle one goes 25, 50, 40. And then the last one you'd end up doing a 25X plus a 50Y equals a 400?
I got all that. And
Okay. Then did you go addition method?
yeah.
Did you drop in
The negative 25?
negative 25? So when you added, you'd get a 25Y equaling, I don't know, I'm trying to do that all in my head and I lost myself.
Oh, I didn't subtract this.
Do you see a mistake?
3.
You find your
yeah,
mistake?
but
Okay.
I still would get the wrong answer. Because then it would be a
25Y I think equals 150?
150. Oh, I see where I'm wrong.
You see it?
Yep, I didn't multiply the 25 into
Okay.
that.
Anybody else something you want me to help you troubleshoot? What happened to you? Yeah.
2.
2, you go X minus Y equals 11?
I just didn't know what. So,
Okay, so difference means to subtract.
on 2?
Oh, I'm sorry, I was looking at 4, my bad. X plus Y equals 63?
Is it negative 63?
Negative 63, yeah.
Yeah.
Then X minus Y equals negative 41?
Alright.
Do you understand how I pulled those?
Yeah.
Okay, then what do you think? How would you solve that?
Combine them.
Yeah, just add them together.
So, it would just be x equals,
2X equals.
2x equals, negative 104.
True. So X equals
Negative 53.
true. and then go to either of those original two equations and replace the x with the negative 52 we just agreed on, and then you can hunt down the y.
Alright.
Anybody else, anything to try to troubleshoot off of 167?
I don't know how to set up for, or probably not do it either.
Okay, so for, when they say difference, we're gonna subtract.
Okay.
So x minus y equals 11.
Okay.
You okay with that? Then they say twice the smaller number. So which of these would be the smaller number? Yeah, we know, I know.
the Y.
Yeah, the y is, how do we know the y is smaller?
Because it makes like not a negative.
Because you
so-
subtract to get a
When we subtracted and got a positive, that tells us the x is the bigger number. So they want us to go twice the smaller, blah, blah, blah. Are you okay from there?
Yeah.
Okay. Yeah, how we know who's bigger and smaller was that they subtracted and got a positive. If this had been an x, would we know who the bigger or smaller was? Not really. So you just have to like guess at that point, I guess. But since they subtracted, they were able to say smaller or larger.
Okay, thank you.
Yep. Anybody else to 12 stuff from 167 stories? Anybody need any troubleshooting?
Just what was the answer on
Answer on 2 was negatives 52 and negative 11. Anybody else any troubleshooting on the beginning 167's first 12? Not for these, no. You needed graph paper for the first 162. I don't think you'll need graph paper again this chapter, but you will need graph paper again this year. But yeah, for now, graph paper is largely on hold other than that first homework from chapter 4. Anybody else, anything from 167, anything that has you jammed up? So if your graphing homework is good, you can send that down from a couple days ago. If your second thing off of 162 is cleaned up now, you could send that. If your 167, 1 to 12 is good, send that. Just make sure you're labeling what page is what, so I'm not trying to solve a mystery what you're doing. Today's lesson, I'm going to start on 167. In the middle of the page, there's a red thing that says, try this, and they're breaking out the old train problems. So train problems, I'm going to suggest you make a table. It's a slightly smaller table usually than the ones we did yesterday. Yesterday we had like an A, a B, and a total. These don't usually need the total line. We can usually just do like an A and a B. Anybody remember for the train problems, the three main like quantities, types of things you're keeping track of? Rate is one, time is one, distance is one. Does anybody remember what order we put them in? Because one times another equals the third. So if we set it up in the right order, we're continuing to just multiply across the table.
Rate plus distance.
That's correct. We usually go rate times time equals distance. If you have any trouble interpreting what's what, rate is always a measurement of how what? How fast. If it's a how fast question, that's rate. Time, how long, and distance is how far. So if you have any uncertainty, take that note and ask yourself that question. Is it how fast, how long, or how far? It's one of those three things that's going to be told to you. The other thing that's different about these, the way I'm going to do them, I'm not going to get a system of equations. I'm just going to get one single equation. I think this is going to be a little easier than the ones we did with the other tables because I don't think you need the second equation. So I'm not going to do it that way. But anyway, this one they say there's a train leaves Barstow traveling east at 35. So I'm going to fill in a label east because there's an east train. There's probably a west train. But I'm going to just... no, the other train's also going east, so that's not a good label. This one leaves first. The other train leaves second. So I'll call it first train, second train in the order that they're leaving because they're both easts. But the train leaves first, traveling east, going 35 kilometers per hour. What's the 35? Rate, time, or distance? That is the rate. That's how fast it's going. Then it says 1 hour later, the faster train leaves Barstow. So I guess I could have called this slow and fast. I mean, those would have been fine labels also. If this train is leaving an hour later, there's two ways you could rig up these time boxes. We don't know either one exactly, so both of them have to involve an extra Y. I'm going to do a T for time, but yeah, we need a variable in these boxes. But there's two ways you could correctly rig up these boxes. If the second train left an hour later, this train left an hour sooner, what's one way we could rig this up? We could go, this would be, let's say I make this one a T.
Then there'd be T plus 1.
This would be a T minus 1 because its time is less because it left later. That would be fine. Go that way, no problem. The other way you could go would be to make this one be T. Then the other one would be T plus 1 because it left an hour sooner. It doesn't matter which system you pick, you just need a system where they're an hour different by adding 1 or subtracting 1 to one of the boxes. What you don't want to do is this. What's the actual difference now between their times? That's a 2-hour difference because you gave that one a head start and you held that one back an hour even beyond that. Now you have a 2-hour difference. That's not what you want. So probably more people wrote the T and then the T minus 1 because I wrote that first. Let's go with that system because we just have to pick something. Then the second train is faster. The second train has to be faster. Why does the second train have to be faster for this problem to work in the real world?
It's gonna catch it.
It's the only way it's going to catch it is be faster. If the faster train left first,
Then it's never gonna get
they're
caught.
never going to see each other again. It's just over. So you want to make sure the slower train has the higher time, faster train has the lower time. Otherwise, this is never going to work. They'll never see each other again if the fast train leaves first. That's all we can get from the paragraph for now is those numbers. Question about those numbers? So as always, we multiply across. So this is 35t. Sometimes people here will put 40t minus 1.
40t minus 40.
40t minus 40, because when we multiply these boxes, it's like there's parentheses here, that's a distribute move, 40t minus 40. Then I'm going to have to look to the story and see what happens. Some of the stories, and I think this is going to be true here, they're going to say that the one train catches the other, and they want us to figure out something with that. Is that what this one is? I'm away from the book. Is it catching the other one?
Yeah.
Okay, so if they're catching each other, what's true about the distances? They're equal. So we need the 35t to equal the 40t minus 40, and we'll solve that. I'll look at the homework problems in a minute. Some of the homework problems are going to say something like they're at the station, and I started to do it this way and then checked myself. If the one train goes east while the other train goes west, would those distances be equal? No, not necessarily. Maybe by luck, but probably not. Then, from experience, anybody remember if they're sending one train east and one train west, what do they usually have you doing with the distances? Add them together to equal some other number they gave you. So if there was some other number in the story, then it's maybe not even worth putting a line into the columns, into the table, but they'd have to give you like a total number, okay? And then you wouldn't need that for all of these levels, but to make the equation, you'd want to go distance plus distance equals some other number that's there. This can't be one of those problems because none of those numbers is there, okay? But if they give you another distance total number, this plus this equals total. Sometimes they also do them like this train is in Los Angeles and this train is in New York, and they drive toward each other and they meet in Kansas City. Well, are the distances going to be equal for that? No, we're going to have to add them up again to equal a total that they give you. So if they give you a total, you probably look to add the distances. Question about where we sit in those couple what ifs? So solve. Get the t's on a side. Get that one out of there.
-5.
-5 equals -40. So t,
80.
80. And now they could ask you a bunch of questions. If they ask you the time for the first train, that would be the 80. If they ask me for the time for the second train, that would be 7. If they ask me the distance for the first train, I would take 35 times 8, that's 280. If they ask me the time for the second train, I wouldn't probably work through this. I would just know that those distances are equal, 280. It's also 280. But we could have gone 40 times 8, because t is 8. 40 times 8 minus 40 is another same 280. Or I could have gone 40 times 7. 40 times 7, also 280. Any distance they ask is 280. Times could be 8 or 7. They asked us, how far from Barstow will the faster train catch the slower one? How far? Answer is, which is the 280, which we were just saying a minute ago. So grand total answer 280. Something about that question. So let's look at homework page, flip one up to 168. Number 3, or 13, excuse me. 13 is a train question. Are the distances going to be equal, or will you add them up to equal another number? To equal what other number? They're equal. Okay, there is no other number, so 13, the one train's going to catch the other train, distances on that are equal. 14, equal, or add them up to equal another number? Add them up to equal 528. Because it's this story, they're leaving, traveling in opposite directions, so add them up. Okay, I'm not going to do that every question for you, okay, but that's your choice you'll have to make. 13, they were equal like this. 14, we add them up to equal 528 because it's more like the picture I drew. 15, you decide. 16, you decide. And then we need to start to worry about new types. Anybody, trains, motorcycles, planes, cars, whatever they do, any vehicle-based questions? Question about that little group to 16? 17, 18, 19, 20 are all the same type of question, so I'm going to get you started on 17. So on 17, they're selling 30 sweatshirts. There's white ones, there's yellow ones, there's a total amount of money they sold. I'm going to write some equations with W for white, Y for yellow, 2 equations, 2 variables. Somebody, anybody, can you make me an equation out of 17 with whites and yellows? W is the number of white sweatshirts, Y is the number of yellow sweatshirts. We're going to do something about it.
Times X plus $10.50, then like parentheses, not whatever W was times minus 30.
You're like a step down the.
31.
You're a step down the road. Well, we better to go with 1050 and just use the Y there. It'll be easier. What did you want to equal?
3 10 60.
Okay, that's the harder equation. So the bigger, meaner, stranger looking equation is going to use all the monies. 995 would have to multiply the white count, plus 1050 would have to multiply the yellow count. Add those up, grand total would be $310.60 worth of money. That's true for the big, scary, long equation. There's a much smaller equation implied in that paragraph. Just W plus Y equals 30. There's 30 total sweatshirts, so when we add those variables, that has to add up to 30. Question about how that went? Okay, 17, 18, 19, 20 all have that in common. There's going to be a basic equation with just single letters that adds up to a number of total counts. And then there's going to be some kind of big, scarier looking money equation. How could I use this tool to make that money equation a little bit less mean? Just take all the decimals out there. If I move this one right too, I can move that one right too, I can move that one right too. They already had all the cents in them, so that makes those all whole numbers. And then I'll leave that to you guys to solve it. Where you sounded like you were heading was a substitution move. Okay, so if we got one of these letters to equal some stuff with the other one, we would have gotten some parentheses out of a substitution move, and that would be just fine. If we want to do an addition move, what number could I create here to make an addition move? Negative 995. Or here I could put a negative 1050. Just as you do those numbers, don't forget to multiply this one also. Like that, you got to go the whole way through and multiply everybody. Up to you how to finish that one. Question about 17. When you're done, you should have words in there, like this many whites, this many yellows. I like to use the W and the Y because then I don't have to remember who's what. W for white, Y for yellow. It's just easier than having to label stuff later. 17, 18, 19, 20 problem type question about that, or anybody not sure if you could finish it from where I dropped you off. 21 and 22 are the same type, so I'll get you started on 21, 22. 21 is a lot like the first four in the sense that you just read the sentence and kind of math a little bit at a time. So I'm going to say C for Carlos is equals 8 older than Maria, 8 plus M. So sentence 1 makes equation 1. Carlos is 8 years older than Maria. Anything about that? Then go to sentence 2. 4 years ago. This whole sentence is now 4 years ago. We're in the time machine, Wayback Machine. Everybody's rewound in history. 4 years ago, we're talking about Maria. So what am I going to do about Maria in the past? Maria minus 4. Was is the exact same verb type as equals, because that's an is. Was, is, will be. That's all the same verb. 2/3. And then I'm not going to just do a C.
C plus 8.
Then I'm going to go C minus 4. Why?
So you have to subtract 4 from both.
He's also 4. The whole thing is 4 years ago. So Maria is back 4 years. Carlos is also back 4 years. For this to work out quite right, I also need parentheses. So that's our system. Maria back in time compared to Carlos back in time, 2/3. Question about that. For the first time in this chapter, you're seeing a fraction. So my suggestion would be, let's try to remember how to clear the fractions. Anybody remember what I can do to this to clear the fraction? Multiply everything by 3. So this would become
3
minus 12. This would just become a 2. And I don't need to touch the parentheses that are kind of locked away. Because if I multiply this by 3, that's going to eventually multiply everything else by 3. We're good on that. Don't multiply this and that, because then you hit a double hit. But multiply by 3's, killed the fraction. This is no longer useful to us other than it was a step on the path. Question about how we got there. Let's distribute, and then I'll give you one more tip. So if we distribute, we're looking at 2C minus 8. That's no longer useful to us. If this is our system, which method is this better set up for? Substitution. Why is this better set up for substitution than the other ones have usually been? The variable's already 11. This C is already alone. That's the thing that I would circle on substitution day. You just stick that here, and then I'll leave that up to you guys to finish that one. 3m minus 12 will live on. 2 would need to distribute all this, but then the minus 8 would still be also hanging around there, and I'm just going to quit talking about 21. Something about 21 type, or how we go from there. 23, 24, 25, 26 are all pretty similar. So I'll do 23. I'll at least get you started on 23. Anybody an opinion on how I'm going to recommend, how you might think to yourself? Yeah, draw a picture. Any geometry story, I think a picture is helpful. So I've got a rectangle. All 4 of these questions are rectangles. And then we don't know anything about anything. So we could call this the length and call this the width. You could argue with me that this should be the width and this be the length, and I'll just quickly grab a rectangle and say to you something like this. It doesn't matter what you call what, because doesn't matter. Okay, so some people get really like, no, the length has to go this way. Well, sorry, doesn't matter, okay. But we've got a length, we've got a width, we've got a rectangle. We'll try to set out here. So the first sentence says the perimeter is 628. So something equals 628. What is the perimeter of that very uncertain shape? 2L plus 2W. Because there's another length here, there's another width there. So one relationship is 2 of the lengths plus 2 of the widths is equal to the 628, they say. Then we don't need the picture to do the second sentence. We just need to take it a word at a time. They say length, I say L, they say is, you say equals, 19, more than, so plus width, W, and there's our system. That's what made this new. 2 equations, 2 variables, there we sit. Is this a better one to add? Like this one to me feels better to add once we create those opposites. You know, create opposites, and it's nice to add. This one looked better for substitution because the letter was alone. This one looked probably better for
Substitution.
probably substitution. Since the L equals this stuff,
That for the L.
that for the L. So 2 distributes this stuff. Don't forget that this is still here. Okay, sometimes people do the substitution and they get some like W's going, and they forget it already had W's. So we're going to get some new W's from our substitution, plus the W's we started with, equals 628. It's all solve. We can come up with widths and lengths from that. If you don't trust yourself to solve, I can continue to tell you where that's going to go, but I don't want to do your homework for you at the same time, but wanted to at least get you started. Yeah.
Shouldn't it be W plus 6?
Yeah, you
Good
did
call.
like
Yeah, I
25.
crisscrossed 25 with 23. Good call. I used 25 sentence, so that was a lot. Length exceeds the width by 6. So let me retread that. If the length exceeds the width by 6, what's this? We're going to add 6. If the length exceeds the width, that means that the length is bigger or smaller? Length is bigger. So take the little one and add to make the bigger one. Length is bigger by 6 than the width. Thank you, that would be helpful. That wasn't going to solve very well with the wrong number for the wrong problem. So it's good we have an audience for these videos in COVID days. In an empty room filming, I'd have gone home happy and that would not have worked well.
That's you can see.
Anybody else, anything else I messed up? Observations? Anybody questions about where to go from there? Okay, well, let's cut that down.